hey, look, here are 900 shifts and now they're assigned to people.
I like to deal with the extremes. We want to get this technology into the hands of people because we believe that this technology has the potential of changing the world, quite literally.
Welcome everyone. Today I'm sitting together with Lucas. He is the lead engineer for Timefold Solver. I'm very excited to be talking to him today. So welcome, Lucas.
It's good to be here.
So how would you actually describe your role and what you do within Timefold?
So actually I have sort of a three-part role. So first, I've been entrusted with sort of the future of the solver as a whole. So I'm responsible for making sure that the solver delivers what it's supposed to our users, to our customers, and making sure that it's a long-term, sustainable, long-term viable project. The second part of my role is I actually have a team of very smart engineers who work on the solver and who deliver features and who fix bugs and who answer community questions. So I try to help them with that. I try to guide them maybe a little bit.
You're leading that team, basically.
Yes. And then the third role, of course, is I'm still an engineer. So I'm also delivering features. I'm also fixing bugs. I'm also answering questions.
So you're still in the nitty-gritty of it all.
Oh yeah, very much.
Okay, so you clearly have a lot of experience if you're going to lead this team. How long have you been going into this space and how much experience do you have with the solver?
So I must have started like 12, 13 years ago.
12, 13, that's okay, yeah.
Because at the time I was responsible for testing the whole portfolio of products, which involved something called OptaPlanner at that time, which has later become Timefold Solver.
Okay.
And yeah, that's how I came to know the technology, and that's how I came to know Geoffrey, our co-founder. And yeah, that's pretty much how it all started, for me at least.
So you came from a technical background, you didn't come from like an operations research background into the solver, or was there already a lot of interest in that kind of space?
So I do have some computer science education, some computer science background, but I did take some operation research classes, but mostly it all became very concrete to me only after I really found out about the project and the problems it solves. It was all very abstract to me at the university, I have to say.
Yeah, I sometimes speak at conferences, as you know, about this topic, and I also see that for people, the fact that you can solve these kind of problems with something like Timefold Solver, it blows their mind because you can tell them about it. But as soon as you show like a cool demo, like, hey, look, here are 900 shifts and now they're assigned to people, then really they start getting it. What I sometimes struggle with personally is trying to explain it to a non-technical person. How would you try to explain it to like someone who doesn't have a lot of experience in this space?
Poorly.
That is an answer, yeah.
No. I usually go for the metaphor of looking for a needle in a haystack. So the haystack obviously is the millions and millions and billions and billions of all the possible solutions that the planning problem can have, and there is a needle in that haystack which you're looking for. That's a solution for your business. Obviously the metaphor is a little bit ruined because in our case there's multiple needles, but I think it still works quite well.
Could you explain maybe to people that don't know what you mean with multiple needles?
Right. So if you're looking for a needle in a haystack, the assumption is that in a very large pile of things, there's one thing you're looking for. That's not the case for us because we are looking for a solution to a problem, which means all the real life restrictions, which we call constraints. But there can be multiple ways of solving that problem with those constraints. So each of those solutions would be a needle. We want to get this technology into the hands of people because we believe that this technology has the potential of changing the world, quite literally. And we believe that to do that, you need to make the technology simple. And personally, as much as I respect operations research and how they push the boundaries of what's possible, I've never been about that. I really want to make this accessible to people. And that's what drives me, and that's what I think makes us different from maybe some of the more research-oriented solvers, perhaps.
Yeah. And in what ways do you think Timefold makes it easier?
So first thing is that we are actually bringing the standard tools of the programming language, right? So everything you do with us is just a domain object like you're used to coding. You write your vehicle, you write your shift. You can persist that in a database. You can load that from JSON through the REST API. So we make this part something you're already familiar with. But there are also other components to that. Like, for example, you need to be able to trust this technology. So we give you the power of explaining what the solver did for you. We show you what constraints are broken, why they're broken, who broke them, how to maybe fix that. We do real-time planning. Essentially, we focus on what the business needs out there in production, as opposed to maybe like pushing the scientific boundary over there. Not really where our focus lies.
Yeah. So I hear two major things. You mentioned something like score analysis, where you can really analyze the code, which is actually a form of explainable AI. This is an AI solution, but it's very explainable. And you can go to your business and say, this is what it is, and this is why this plan is better than that plan. You can really prove it. And the second one you mentioned is that it's adaptable to the real world. So if changes come in, that it's not this black box and it will spew out something completely different, but you can actually sort of see how a change impacts the entire system. And I think those two are very powerful. So one of the reasons why I wanted to talk to you is that it's been 2 years since the big fork away from OptaPlanner. So congratulations on the 2 years, first off. What are like the major improvements that you think have been brought to Timefold that you are most proud of?
Right. So we've actually been trying to compile a list recently, and the list is really like even I was surprised how long the list was.
Well, it's been 2 years of your life, so I hope you've been doing something in 2 years.
True, yes. So we've had many of sort of, I would say, smaller improvements, but some of the things I would mention would be things that are like not catchy, but they are very important for the solver. Like, for example, the feature about the list variable, which allows you to chain things in time. That has received like so many improvements in terms of performance. It's received support for pinning. It's received support for unassigned variables.
Okay.
Now we are actually working on bringing it together with the basic planning variables. So that's also something that was never possible before.
So that last one would mean that you could combine a regular planning variable with a planning list variable.
Yes.
Okay, that's something that I've personally struggled with sometimes. People have that. Yeah.
We are aware of that, and it's a feature that's been missing for a while, and it needs to be addressed. From the things that are probably more visible, so we recently introduced a preview feature called Declarative shadow variables, and the feedback we got on that was just incredible. So it's obviously something that people have been looking forward. It's a way how to solve before and after relationships in your variables. So if you know that two people can only do the same job at the same time, it requires two people. You can actually clearly define that now in your code. So it's something that people seem to really love. And we are now improving its performance, and we are catching some bugs. So hopefully it's going to be a full feature soon.
So you mentioned the preview feature. Could you maybe explain shortly what a preview feature is and why they even exist?
Right. So it's a new thing we introduced in Timefold Solver, where we noticed that sometimes we deliver a feature and we make the API public, and from the point the API is made public, we make strict commitments to never ever change it again.
Backwards compatibility, not break. Okay, yeah.
Right. So at the same time, we noticed though that this sometimes doesn't lead to the best possible APIs, because we need a way of learning before we make something actually set in stone. We want to have some period for learning from how people use the feature, and sometimes that leads to us actually changing the API. So this actually happened very frequently with constraint streams, which most of the original constraint streams API is now deprecated.
But it's still there because
It's still there
it's compatible. Yeah.
because we make the promise, but still the API is full of like these deprecated methods now. And the way of doing a preview feature first is so we get to do it right the first time so that we don't later have to deprecate all of these things which we figured out maybe weren't the best thing to do. So now this one feature is declarative shadow variables that is now in preview, and hopefully in the next 2-3 releases we are going to finalize it based on the awesome feedback we got, and we are really happy for that feedback.
So people can already use it, but how can they use it now? Because it's in the solver, but it's not final, so it might still change. But if people want to use it and provide some feedback on it, how would they go about that?
So there is a simple switch in the settings. You just say, I want to enable that preview feature. And like when you do, you will get full access to the API. You will be able to do everything it can do. And whatever things you run into, we want to know. That's why it's a preview. We want to learn from that, and we want to make sure we deliver the best possible API we can. So, which then we will commit to for many, 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 many years.
So that sounds like a great way to contribute to the solver without actually having to code on the solver yourself. You use it and then just provide feedback.
Absolutely.
Right. Excellent. Besides the solver itself, what are you most proud of after you've joined Timefold?
Okay. So this may be a little bit hidden from view, but personally, I like to deal with the extremes, and sometimes you get the occasional customer or the occasional user who brings something that you thought you were never going to be able to do. And then you think about it, and then you do the engineering bit for months and months and months, and then it becomes possible, and then you're kind of proud about yourself.
And could you give an example, or is that off the record?
I can probably do something like vaguely. So we had this case where there was a need to solve a problem of roughly 100 times bigger than I ever thought we were gonna have to solve. And when I was first looking at the problem, I said, okay, that's never, there's no way how we will ever be able to do that. And then after some work, suddenly we've been able to solve a problem which was 1/10 of the size, and then half of the size, and now we can solve the full problem. So
cool.
So that's what I like to do. I like to live in these extremes.
So Lucas, we work at a planning AI company, which has the abbreviation AI in it. How do you think AI, and maybe GenAI specifically, will impact our industry?
Right. So you would talk yourself about how the LLMs are currently not the solution to planning problems. And honestly, I don't think there will ever be. We'll see about that.
This might age badly.
But that doesn't mean that GenAI has absolutely no space here. Like, I think there is plenty of space for GenAI on the boundary between the human and the computer. Like, for example, we can have, and we've been experimenting with that, like we can have the platform try to explain in human language, like what are the problems with your solution, like where to better focus your resources so that the solutions can be better. Yeah. Maybe it can write constraints based on definitions in human language. So there are plenty of opportunities, I think, for GenAI, just not in the scheduling and planning itself.
All right. We're going into a promising future anyway. An interesting future.
Yeah. Interesting, definitely.
So to not take up too much of your time, I have one final question. As the Solver team lead and with your Solver colleagues, what is something very interesting that you're working on now? Do you have something cool in the oven?
Okay. So I already mentioned that we are making some significant improvements to the list variable, features that people have been actually calling for. So stay tuned to that. We are going to be finalizing the declarative shadow variables, and we have something baking. It's called move streams, okay, which is probably the last component we haven't touched yet since the old days of the solver. And this is going to allow people to properly leverage the solver to find more needles in bigger haystacks.
Okay.
And that's something that we're really looking forward to. It's a long-term project. It's going to take a while, but when it's done, it's got to be good.
All right. Sounds very excited. Thank you so much for your time, Lucas.
It's been a pleasure to be here.
I have to look. No, I can't.
Look at me. Look at me.
Click like and subscribe. I mean,